Here's a question. What does snooker and boxing have in common? At first glance, maybe not a lot. In the first, you're trying to pop balls in pockets. In the second, trying to land punches on your opponent. And doing your best to avoid theirs. Yet, there is a lot in common, and the answer is actually pretty simple. Both sports are defined by collisions and their outcomes. How things collide, balls or boxing gloves, matters. So we need to understand the principles of momentum. The science of things colliding has an incredible array of real-world applications, like reducing car and train crash injuries. In simple terms, we know it as mass in motion. Let's unpack it. This is Think 4. Momentum is simple. We take an object's mass and multiply it by its velocity. It doesn't really matter whether we are talking about a boxing glove or a billiard ball. The outcome of this is the object's momentum in kilogram meters per second. So an 80 kilogram person running at 5 meters per second has a momentum of 80 times 5, or 400 kilogram meters per second. So why do students lose marks on such a seemingly straightforward concept? The answer is that we often deal with two objects colliding, and we need to take into account both of their momenta. And here is the absolutely most important thing to remember. Momentum is a vector, and it must be conserved. So what do we mean by that? Well, it means that as a vector, direction matters. So if things are moving towards each other, the outcome is different than if one is stationary and the other crashes into it. What does "it must be conserved" mean? Simply put, the sum of all the object's momentum before the collision is equal to the sum of their momentum after the collision. Let's consider two objects moving towards each other with an identical speed and mass, but in the opposite direction. What are their respective momenta? Object 1 has a mass of 5 kilograms and a velocity of 10 meters per second to the right. Object 2 has a mass of 5 kilograms and 10 meters per second to the left. Before the collision, the sum of their momentum, if we consider that object 2 is traveling in the opposite direction and is therefore a negative, is 0. After the collision, what happens? Depending on the object, either the objects stop dead in their tracks or they bounce off in opposite directions at equal speed, so momentum is conserved. What about if one of the objects is stationary? Say if a rugby player is standing ready to make a tackle on a player charging towards them. If we assume that the defender clings onto the player running at them when they make the tackle, we can consider them as one big joined up object after the collision. So if a 100 kilogram person is sprinting at 6 meters per second at a stationary 80 kilogram person, what is the momentum before the collision? The 100 kilogram person has a momentum of 600 kilogram meters per second before the collision. However, the stationary person has a velocity of 0, therefore has a momentum of 0. So the total momentum before and after the collision will be 600 kilogram meters per second. After the collision, if the smaller 80 kilogram person is hanging on for dear life, we can now take them as one big object of mass 180 kilograms. And crucially, they will both be traveling at the same speed if they are attached. Therefore, after the collision, we will have 180 kilogram of mass that must have momentum equal to 600 kilogram meters per second. So our calculation is just 600 divided by 180, which gives us a new velocity of 3.3 meters per second in the direction the 100 kilogram player was running to begin with. So remember, momentum is mass multiplied by velocity. It is a vector quantity, it must be conserved, the sum of all momentum must be the same before and after the collision. The principles of mass in motion hold up on any terrestrial scale, so understanding momentum will help you reduce collisional impacts in car or train crashes. Or, if it's just the effect of a collision of a snooker ball or a boxing glove you're trying to predict, this stuff matters, though it is perhaps more important to fully understand the impact of the boxing glove. This was Think 4. Thanks for watching.